Hello everyone. So, we will continue with the topic filter fabrics. So, what we have discussed the basic mechanisms of filtration, and then we have discussed the measurement techniques of filtration efficiency and pressure drop and other fabric related parameters. Now, we will discuss various other parameters. So, the pore structures, as I have already mentioned, there are three different types of pore structures. One is closed pore, which is blocked from all the sides; blind pore, it is open from one of the surfaces and it ends within the structure, and through pores, that is the pores are that starts from one surface and ends at other surface. So, this through pores are basically important for filtration application. Let us discuss the measurement technique of pore structure. The pore structures are measured using porometer. There are different types of porometers. So, these are used to measure the pore structure of membrane or filter fabrics, and these are important for filtration characteristics. So, the basic working principle of pore measurement is based on basically capillary flow principle, and this is used to measure the pore size distribution of filter fabric. The techniques are, one is intrusion porosimetry, that is mercury, it is used mercury. So, here mercury at high pressure is forced into the cavity of the porous filter fabric. So, here mercury is being forced through this cavity, and depending on the pore structure or pore size, the pressure will vary. So, for finer pore size we need higher pressure. So, pore dimensions are calculated using penetration pressure data. So, indirectly we can calculate the pore dimension. Next principle is that physiosorption, that is physical adsorption. Here liquid nitrogen is used. This liquid nitrogen is adsorbed on the surfaces, different surfaces of porous solid. This allows to calculate the surface area, internal surface area of the pores, and indirectly we can calculate the dimension of pore. Next technique is that liquid porometry. Here we use two different liquids. One liquid is having higher surface tension and another is having lower surface tension. So, this dark color is showing the liquid with lower surface tension, that means it can wet the surface easily. The wetting liquid is displaced from the pore by another wetting liquid with higher surface tension. So, this liquid with higher surface tension, when we allow it to pass at higher pressure, so this liquid will force the other liquid with lower surface tension to push out, and accordingly we measure the pore dimension based on the liquid flow velocity. So, this flow meter or microbalances are used. Next technique is that capillary flow porometry. Here instead of this liquid with high surface tension, we allow the liquid to displace by an inert gas. An inert gas is used, and based on the gas flow rate we measure the pore dimension. So, here capillary flow porometry, the principle is that an inert gas is used to displace the wetting liquid from pores. The gas flow rate achieved at certain pressure is measured using flowmetry. So, one flow meter will be there. So, at certain pressure we measure the gas flow rate, and in this principle we measure only through pores, pore dimension of through pores which are important. But if we see textile medium, almost all the pores are through pores, because the chances of closed pore and blind pores are rare, because these are made from the discontinuous or continuous fibers. So, capillary flow porometry can be used to get idea about the pore dimension of filter fabric. The process is that, as I have mentioned here, the sample is first wetted with a liquid of low surface tension, so that it gets wet easily, and consequently all the pores are filled with that liquid. The wetted sample then is subjected to increased pressure of an inert gas. When this pressure of gas, P gas, exceeds the surface tension of liquid in the largest pore, it will start pushing out the liquid. So, at largest pore the liquid can come out easily. So, it will start from the largest pore. So, gradually we increase the pressure P gas, the flow through the smaller pore will start, and ultimately total liquid will come out from the structure. So, to get the actual result without any error, we have to run the process in wet run and dry run principle. In wet run means the gas is applied when the structure is saturated with liquid, and dry run the sample is dry without liquid in the pore. So, pore size distribution is then calculated based on the flow data in wet run and dry run. So, there are different parameters. These parameters are fast bubble point. So, this is the pressure at which the fast continuous gas bubbles are detected. So, if the pore size is more, this pressure will be less. So, from there we can get idea about the pore size, smallest pore size, mean flow pore diameter, gas permeability. That means, when we use the dry run, from there we can get the gas permeability, cumulative filter flow, differential filter flow, and corrected differential filter flow. So, these are the parameters we can get from the porometry result. So, after pore size we must assess the dimensional stability, whether there is a change in dimension during the application, during wetting, or even during heating. That is very important for performance. Tensile strength characteristics they are required. So, strip test, grab test. So, these are the different tests available. So, results are breaking force, breaking extension, modulus. These are important because during application or handling we must know the tensile characteristics of filter fabric. Tear strength is also important, tongue tear strength. So, testing machine, any constant rate of extension machine can be used. So, here maximum force, average force of the tear strength sometime used. So, these are the parameters which we can use for tear strength measurement of filter fabric. Bursting strength is also very important, particularly for filter fabric at when the pressure difference, that is pressure drop is high. So, it is measured based on the diaphragm type bursting strength tester. So, burst index is measured, which is actually bursting strength per unit mass. Now, we will discuss different types of products which are available commercially. As far as the shape, we can divide the filter fabrics in different classes. These classifications are: first, flat filters. The flat filters are the filters which the shape is a flat, and this can be used without any frame, or we may sometime need frame. So, for smaller size with a thick or stiff filter fabric, we may not need frame. These are used for bulk filters. So, that this bulk filters, the thermal or chemical bonded nonwovens are used, or sometimes needle punched fabrics are used. These bulk filters are basically used for without any frame, and thin filters are thin woven fabric or knitted fabric, spun bonded or melt blown fabrics are used. So, here we can see this is a supporting grid is there. So, this is bulk filter and thin filter. Bulk filters are used where we need to have depth filtration, and thin filter, these are used where we need a surface filtration. So, these flat filters are used where cheap filtration solutions are required, like vacuum cleaner, kitchen digesters, paint box. These are the applications where the bulk filters or thin filters are used in flat form. The main drawback of these filters are the high pressure drop. Although these are simplest in construction, we do not need any fabrication. In bulk filter or flat filter, suppose this is a filter fabric, air is passing through. So, P1 is the pressure on upstream side, P2 is the pressure in downstream side. So, pressure here is basically the force per the unit area. This is the pressure exerted on the filter fabric, and higher pressure means higher energy required, as I have already mentioned. Also, this high pressure will exert extra stress on the filter fabric. In that case, the filter fabric may get deformed. On the other hand, if we want to reduce this pressure drop, this pressure if we want to reduce or we want to increase the flow rate. So, here the flow rate is depends on the area of this filter. So, this area, if we can increase the area to say A dash, then we can reduce the pressure drop where A dash is more than A and P2 will be less than P1. So, for same area of application, how can we increase the area of filter? So, the way is that if we can incorporate pleat, so the effective area or effective zone of filtration or air flow remains same, but the filters are pleated. So, the actual area of filter fabric has increased, therefore, the pressure drop on the filter. So, pressure difference between the upstream and downstream side has reduced, and as area of the actual area of the filter has increased. So, we can have the air flow rate higher, at higher rate air can flow. So, the next type of filter based on shape, it is a pleated filter. So, here we can see the filters are in the form of pleats, the pleats are incorporated and here the air is flowing with less pressure, pressure requirement is less. So, air flow direction. So, this total area is been exposed for air flow. So, we have got air. So, pressure drop is reduced. This filter can be used for HEPA filter. So, high efficiency particulate arrestance, as the filtration efficiency can be high with the lower pressure drop. So, we can use the filters with lower pore size. So, these are used in industry or cabin air filter. So, based on shape, the next filter is that it is called pocket filter. The shape is almost similar to pleated filter, but here this filter is placed in a frame. Here filter thickness is similar to the other filter dimensions. At first they are stitched or bonded each other and to form a pocket, and then it is embedded to a frame. Here frame is required. So, main disadvantage here is that here the dimension is high, because we have plates of very higher depth to form pocket, but main advantage here is that the pressure drop here is much lower than normal pleated filter, because all these inner surfaces are used for filtration. So, this we can use for pre-filters in HEPA filter or final filters for less superior industrial application. So, this we can use for pre-filters. Here from this side polluted air is entering and clean air is coming out, but the basic mechanisms are similar to the pleat filter, only difference is the dimension. Next is the cartridge filter, and which is very popular both for air filtration and liquid filtration, and this cartridge filter main advantage here is that the space required here it is very small. So, lower space requirement is here. These are basically in tubular in size. So, we need one perforated frame for this, and in this this is perforated frame. This is only for support. This can be metal mesh or maybe polymeric cylinder, hollow cylinder with mesh. Now, on this we can wrap the filter fabric. So, we just wrap this is the filter fabric. It could be non-oven, oven. So, this is the filter fabric. So, if we just simply wrap around this, and this will be effectively the cartridge filter, and one side is blocked and other side its outlet is there. So, this is the outlet side. Now, air or liquid penetrates from the surface, that is polluted air is entering from the surface, and after filtration the clean air is coming out. So, after certain time we can just clean the surface, outer surface, to reuse this filter once again. If the filter is totally choked with the particles, we can reuse the structure, we can remove the filter fabric and replace it with a newer fresh filter fabric, or we can totally replace the cartridge. Another way to use the cartridge filter, here what we have done, we have used a flat filter medium. So, if we see the cross section here is an, this is the support and the filter is wrapped like this to form certain width. If we want to enhance the filtration performance by increasing the filtration efficiency and reducing the pressure drop, we may use the pleated filter. So, the filter fabric is wrapped in pleated form, but here the stiffness of filter fabric should be high. So, we can use spun bonded, heat bonded filter fabric here. Another way to use this cartridge to wrap coarse yarn or roving if we wrap around this frame. So, this is the, suppose this one is roving or coarse yarn. Typically, we can use the coarse sheath type of yarn, and if we wrap, we must ensure that proper traverse speed, so that there should not be any gap. We can have a number of layers and form the cartridge type filter. So, this type of roving based filters are used mainly for wet filtration. So, for liquid filtration we can use this type of filter. So, flat or bulky filter, directly we can use non-woven fabric, say, and here the pleated filter, and these cartridge filters are used where space requirement is less. So, where we do not have larger space. So, in those places we can use, and at the same time we require higher filtration efficiency. So, inside the car, the filters used inside the car or various industrial applications where the space available are less. So, this type of cartridge filters are used, and this is very often used for liquid filters, that water purifier or different types of liquid filters we use. So, the polluted air is entering through the surface and the clean air is coming out from the axis. Next is that back filter. So, the principle wise this is similar to the cartridge filter. So, if you assume that the size of cartridge is very big, then we can conceptualize the back filter. So, let us see the cartridge filter here. So, cartridge filter, what we have seen, this is the cartridge, and we wrap the filter fabric. This is the filter fabric. Okay. But in case of back filter, we have larger size of frames, very large frame. So, this is the metallic mesh, this is used just for support. And the prefabricated bags, filter bags are used. These bags are taken here and just placed over this. These are hanging. This is back filter. Okay. This frame is only for support of the bag, and frame is required, otherwise the filtration process is not possible. And here again the industrial polluted air enters through the surface, and the clean air. So, this is clean air which comes out from this, and it is getting mixed with the environment. So, we cannot throw the polluted air in this in the environment. So, these are used for say cement industry or textile industry, where dust load is very high. So, these are the dust particles, okay, which are retained, arrested at the surface. So, in actual practice we will see that number of bags are large. So, in a big cement industry this can go maybe hundreds. So, this type of bags, and this size, if you see actual, this size height maybe 10 feet, maybe 20 feet, this very big size. It is a total filter, that back filtration zone is, it is a big hall. Okay. So, there are hundreds of such bags are there, and the polluted airs are entering into this bags through the surface, and we get the filtration. So, large amount of air is passing through, these are clean air, these are the clean airs, and here it is a polluted air. Okay. Now, with the time what happens, this surface is loaded with the filter, and gradually the pressure drop is becoming high. So, this dust cake needs to be removed, cleaned. So, here we cannot remove these bags frequently, because it takes time and it is a loss of the productivity. So, what is done here, high pressure air is being injected, it is called pulse jet. Very high pressure air is injected for very small span of time. So, with a few seconds, say 1 second, 2 seconds, so which will actually shake this filter media, and the dust cakes formed in this on the surface of this filter get released and will be collected at this point. So, there will be dust collectors, and this dust collector will actually collect the dust and it will be taken out. So, this is the dust recovery system. So, here like in cement industry we are not wasting this is a product basically fine particles, this we can reuse this one, and this quantity is in huge amount. Okay. And after certain time, so after maybe few months or certain time depending on the dust load or particle distribution. So, once this filters are clogged with the particles, so we may replace, or if in case of it is damaged we can replace this. So, commonly many bag filters, as I have mentioned, are used for one application. There may be hundreds of bag filters. Most of the dust is collected on the surface of the filter. When the increasing pressure drop reaches to a set value, so it will measure the pressure drop. The filters are cleaned by short burst of compressed air moving in the reverse direction. So, typically there is a shaking, we can place this blast inside also. So, this will give us the shaking and it will remove the dust particle. This is the diagram as I have shown here. This is a dust collecting system. Okay. These are the filters here with the dotted line, these are the frames, inlet of polluted air, and this is a clean air. So, after understanding different types of filters based on their shape, the relationship between filter variables and filter properties, this understanding, it is extremely important for application. So, the filter variables, the filtration variables is that first is filter variable. So, for any filtration we must know what is the type of filter, what is this mass per unit area, thickness, what type of fibers are being used, whether it is a heat shield or needle punched, whether it is oven or non-oven. So, these are the variables we must keep in mind before selecting the filter. Flow medium variables. So, if we try to select a filter, we must understand, we must know for which application, whether we want to use it for very sophisticated application or whether the dust load is high. Do we want to use for cement industry or textile industry or maybe high performance that like a hospital. So, that those information one should have. Another parameter we must know, that is the particle variable. What is the particle dimension? It is a very fine particle or is it a bacteria or it is a coarse particle. So, this type of information we must know before we go for manufacturing the filter. Then filtration mechanism we must understand, we must take into consideration whether it is by diffusion we want to use by diffusion, whether it is a direct impaction, inertial deposition. So, these are the different filtration mechanism we must take into consideration along with the filter variables. Then what are the filtration parameter properties we must take into consideration, like whether do we need higher filtration efficiency or do we want to reduce the pressure drop, whether we need higher life or we can have at lower life. So, if it is very expensive or changing, if it is changing, if its changing is difficult. So, we must consider for higher life. We must understand the resistivity against the surrounding condition, if the temperature is very high or stress is very high. So, accordingly we must select the filter fabric. So, all these parameters we must understand, like for say pre-filter of any system, we must concentrate on low pressure drop. We do not need high filtration efficiency initially, it must be gradual filtration. So, when air flow rate is very high, so flowing medium variable like air flow rate is very high, in that case we should not concentrate on filtration efficiency, we must concentrate on pressure drop. But as air flow rate reduces, we must then take into account of the filtration efficiency. Now, let us try to understand. Suppose a filtration system, this is a filtration system, it consists of a number of filter layer. This is one filter, filter 2, filter 3, filter 4. These are the filter layer. Here say air is dusty air is with dust particle. This filter 1 here if we target the maximum filtration efficiency, then total system will collapse. We must allow the air to pass through initially at certain velocity. Here velocity of air is highest. So, in this case pressure drop should be as low as possible. So, we will use a filter medium with low pressure drop with open structure, but when once it is coming, so air outlet is there, once it is coming in this next place, here we will have, so this will arrest a larger particle, so smaller particle is again coming. So, here the air velocity is reduced and smaller particle again much smaller particle will come. So, gradually the air velocity will keep on reducing, but at this point here the very fine particles are coming out. So, if we try to see the mechanism which we would like to adopt here, in first place we can adopt the inertial impaction, because the larger particles will go at higher speed and it will get impacted, and accordingly this will the filtration will take place. But at end point where very fine particles are there and air velocity is very low. So, at this stage we must concentrate on the Brownian diffusion mechanism. So, diffusion, that mechanism wise we can select, and accordingly we must select the fiber fabric parameters. Here we can also use the electrostatic filter. So, understanding this relationship is extremely important for proper utilization of filters. So, there is a parameter which is called MERV, minimum efficiency reporting value, as I have mentioned. So, this is the American system of grading the filter. MERV value shows the filtration efficiency. So, dust holding capacity was added in ASHRAE 2007, dust weight arrestance was added. As per this standard, the lower particle size with micron 0.35 or 0.5, around 0.5 micron size, these are used for respirable size particles. These are the respirable size particles used for basically this fine filters are required, and these are the coarser particles for daily common applications. And if we want to remove these particles, we need fine filters with higher filtration efficiency. Let us see the filters with different MERV value and where are they used. Like MERV 14, which is a very fine filter used for very fine particles, it is around say 0.4 micron to maybe 2-3 microns. It is used for filters in hospital application, where we have to eliminate the very fine particles. Then MERV 13 with lower filtration efficiency, the filters with higher pores, MERV 11. So, there are different applications. So, MERV 13 is used for average commercial applications, MERV 11 is applied in commercial buildings, MERV 8 pleated filters. So, these are used for air filters, and these are the coarse filters used for as pre-filters. Okay. So, MERV 13 to 16 means very high filtration efficiency with the particle size range is 0.3 to 1 micron, all bacterias, okay, tobacco smoke, okay. These are coming in this range, used in hospital, general surgery. Okay. So, 9 to 12 its range between 1 to 3 microns, again used in superior residential buildings, hospitals, in laboratories. 5 to 8 particle ranging between 3 to 10, MERV 1 to 4 very large particle, that is 10 micron and more. So, minimum filtration, it is residential window air conditioner, they use this type of filter. So, based on MERV value we can select the filters at different applications. So, if we divide the filters based on their filtration characteristics, there are different types of products. HVAC filters, which is heat ventilation air conditioning filter, HVAC filters, HEPA filter, high efficiency particulate air filter, ULPA filter, ultra low penetration filter, air purifying respirator, back filters. There are different types of products available for air filters, and for liquid filters the filter paper, cartridge filter, back filters are also used. HVAC filters are subdivided into 3 categories. Fiberglass filters, basically the glass fibers are used with 15 to 60 micron diameter. These filters are basically used for pre-filters with high porosity, protect air systems such as fans, motors, cooling coils, heat exchangers, fiberglass filters, and plate filters where natural and synthetic fibers are used, and electret filters, electrically charged fibers are used here. So, HVAC filters are mainly used for coarse filters. Next category is that HEPA filter. In HEPA filter, as per as European standard, these are classified into 5 categories starting from H10, 11, 12, 13, 14, and this classification is based on the filtration efficiency. H10, the filtration efficiency is 85, it goes up to 99.995%. HEPA filter is widely used for air filtration in general applications. Third is ultra low particulate air filter, where this series is starting from U15, U stands for ULPA, ultra low particulate air. In HEPA filters it ranges with H. So, U15, 16, 17, their filtration efficiency are more than the HEPA filters. They are used for fine filtration. Here microfibers are used, glass microfibers are 0.2 micron fibers are used, and mainly wet lead non-woven technologies are used to manufacture ULPA filter. Next filtration is that air purifying respirator. These filters are defined as device designed to provide the wearer with respiratory protection against inhalation from hazardous atmosphere. So, this is used for respiratory protection. The examples of APRs are face mask, gas mask. So, activated carbons are used to absorb and remove dangerous chemicals in addition to the particle filter or fumes in the air. So, if we want to use the filter or APR, air purifying respirators, we must understand the particulate matter in the atmosphere. So, atmospheric particulate matter, which is also known as particulate matter, these are microscopic solid or liquid matter suspended in the atmosphere. Their source are different, maybe natural source or man-made source, but these particulate matters are actually harmful for our health, and we must actually arrest this particulate matter from entering into our body. So, the different subtypes of atmospheric particulate matter are suspended particulate matter SPM, respirable particles which are very small in size, inhalable coarse particle with a diameter of 2.5 to 10 microns, and fine particles with diameter 2.5 micron or low. So, we can express in terms of PM 2.5, that is the amount of quantity of particles present in the atmosphere with size 2.5 micron or less. PM 10 means particulate matter with size 10 micron or less. Ultrafine particles, soot, there are different types of particles. So, what is particulate matter 2.5? In short, it is called PM 2.5. The term fine particles or particulate matter 2.5 refers to tiny particle or droplets in the air that are 2.5 micron or less in width. That means, if we try to express the fine particle, we normally express PM 2.5, or if we try to express in terms of coarser particle, we normally express PM 10. Now, this is the typical yearly average air. So, this yearly average 50 micron per cubic meter, it is expressed in 50 microgram per cubic meter. So, PM 10, its level 50 means the particles of size 10 micron or less. If we take the total mass of particle in 1 cubic meter volume of air, it will be around 50 microgram, that is called 50 microgram per cubic meter. So, PM 2.5 will definitely be less than PM 10 in value, because here its presence here is the 2.5 micron or less. From here we can see in the air the majority of the particles are of size 2.5 micron or less. So, that is obvious, because larger particle normally get settled due to their mass. What is N95? N95 it is used in US. So, US standard is N95 mask, which is equivalent to European P2 and P3 mask, with P3 offering higher protection. The N95 means it is a particle filtration efficiency more than 95% with the particle size of 0.3 micron. So, that is the standard mask which we use for infection control. So, P95 mask is used. Now, we will end the session of air filtration. Thank you.